Hi y'all, today we're going over dimensional analysis, also known as the factor label method and stoichiometry. You can find this information in Module 2, Lesson A. Some learning goals that we are going to go over today are definitions, where it can be applied and who can use it, some common conversions, and at the very end we're going to go over 3 examples. What is dimensional analysis? It's pretty much when you convert one set of units, given units, to another set of units that you do not know. If you were ever wondering who could use this, it's pretty much anybody from researchers to construction workers to bakers to painters. The list can go on. When can dimensional analysis be used? It's whenever you have a certain value and you want to determine an unknown measurement. Here are some common conversions that we run into when we're working in chemistry class. It's grams to moles and moles to gram. We have now reached the fun part of our lesson. We are going to go over 3 examples, one non-science related, one science related, and one chemical formula related to dimensional analysis. For our non-science related question, we were asked how many cups of salt would be in a gallon's bag. In the problem, we were given 1 gallon. For every 1 gallon, there's 4 quarts. This allows the gallons to be canceled out. For every 1 quart, there is 4 cups. Now the quarts can be canceled out. When you multiply across, you get 16. When you multiply on the bottom, you get 1. In total, you'll get 16 cups. For a science-related problem, say we had a UTSA runner who ran about 5 kilometers. How many miles would that be? So our known value is 5 kilometers. For every 1 kilometer, there's 1,000 meters. That allows our kilometers to be canceled out. So I went ahead and looked up the conversion from meters to miles, and this is what was given. That allowed me to cancel out the meters. Once you multiply everything on top, you get 3.105 miles. Here's how to use dimensional analysis when trying to convert grams of a given chemical equation to find grams of the product in the given equation. So we know that there are 200 grams of C6H10O4. We know that for every 1 mole of C6H10O4, there is 146 grams of C6H10O4. That allowed us to cancel out grams of C6H10O4. We also know that there is 1 mole of C6H10O4 for every 1 mole of C6H16N2. That allowed us to cancel out moles of C6H10O4. We know for every 1 mole of C6H16N2, we're going to have 116 grams of C6H16N2. That allows us to cancel out our moles of C6H16N2 and leave us with grams C6H16N2. When we multiply everything on top, we get 23,200. When we multiply everything on the bottom, we get 146. When we divide those two values by each other, we get 158.904 grams of C6H16N2, which is the total product answer. This is a list of references that I used to help create this presentation. I'd like to say thank you to our professor for signing this project, and thanks to everyone who is watching this video today. I hope you learned something new and exciting.